I propose is we go through homework number 3 first, then we go number 2, and then we do number 1. What do you think? Yes.
Like all first to like refresh the concept.
You want me to do the tutorial question, homework question? Okay, I will do that. Yes. Homework, homework. That's what I said. So you want me to derive, and you want me to do, why not the deriving part? You can watch my video. Okay. So how about if I do homework 3 first? What do you think? Yes.
Would we often derive things?
Oh yeah. What do you think? I could do it. You could do it also, right? Wait. So you okay? I could do it, and then you don't need to do, right? Yeah. I'll start from homework number 3. There's 2 students that came into my office, and I have to apologize to them. That day, my mind was not right, and I don't think I explained the concept properly to them. So it's classmates. So I'd like to apologize to them. Okay. I try to clarify things better now. Okay. So what I'm trying to clarify is this. They ask a very good question, and it's a conceptual question. They asked me what happened to the mass. Okay. So I will do this first. Okay. I will go into, I'll clarify this, and this will help in homework number 3 also. Okay, watch this. So let's look at question that I like to address is what happened to mg. Okay. What happened to mg? Okay. So I believe homework 3, question 2, there was a mg term. Okay. So what's going on? Okay. So coming back to fundamentals again, we look at stage 1. Where we have a spring only. Okay, so this is stage 1, spring only. Okay, so that is our system, right? And then we put a load or a mass at the end. So when we know that we put a mass at the end, the spring becomes longer. Okay. So if I were to sketch a horizontal line across, and then another horizontal line across. Right. This distance is known as delta S. Delta S meaning deflection or meaning static deflection. Okay. So the term used over here is static. So at stage 2, which I've just drawn, is we have the spring and mass in static equilibrium. So for this case, the term starts where we call it static. Okay. I'm going to address that coming down is my x. Okay. Coming down is my. So if we use our right-hand rule, this will be our x, and this will be our y,
And coming out, this is our rotation about Z. Knowing that this is a static equilibrium, we know that summation of forces in the x direction must be equal to what? 0. Seen this before? Where? Where do you see this before? To what? To P04, right? If we start sketching the free body diagram, right? If we start sketching the freaking big free body diagram, we know that the mass is coming down with what? Mg, right? We also know that over here, we have a spring force that is also due to what? Mg. Okay, right. So from here, summation about forces in the x direction is equal to 0, right? So what we get is, so positive is coming down. So mg minus fs is equal to what? 0. So mg fs is also equal to mg. The whole thing is equal to what? Are we clear? Okay. So it's supporting the mass. So we also know that fs, right? fs over here is equal to, or fs is equal to mg, and this will be equal to k over static displacement of delta s. Delta s is your static deflection. So from here, in order to calculate the stiffness, k is equal to mg over delta s. So that is the consideration of the what? Always remember, the spring force always what? Always opposed to the weight. Okay, if the weight is coming down, the spring force will go in which direction? In the opposite direction. Okay, we have to get this clear. If this is not clear, I'm worried. Not worried, but I want to be sure that you guys are comfortable. Because I realized that the solution did. Go on. Testing. Hello. Are you dead yet? Hello. Go on. My bad. Ay, 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 ay. Hello. Yeah, you can hear me now. Great. Right? So in the next one, stage 3, you still have spring and mass. However, okay, however, there is a dynamic, or however, we want to understand the dynamic behavior of the system. Dynamic means everything is under what? Motion. So what we do now, okay, yeah, all right, let me move this a bit up. Okay, and this is our spring. Okay, this is still our mass. Okay, so X is positive M. However, we want to excite the system in mx double dot dot. Not excite the system. What we are going to do is we are going to declare summation of forces in the x direction is not equal to what? 0. Okay. We don't want it to be equal to 0, but we want it to be mx double dot dot. F is equal to ma. Okay. When the resultant force is equal to 0, means you are doing static analysis. This case it is not. That is the principal difference with 2P04 and 2Q04. Very clear. Okay, in 2P04, everything equal to 0. Yes or no? 2Q04, nothing is equal to 0. That's why you can't fail. Sorry, it's so bad. So in this case, we have a reaction force. Hey, come on, Eugene. We have a reaction force down here. This reaction force is due to Kx plus by what? Plus by mg, right? And then we know down here, do I need to put down mg over here? Yeah, down here also have mg. Okay, right? It's going down. So down here, you still have your what? You still have your mg acting down here. So now we do summation about forces going down is positive. So mg minus by kx minus by mg. This is equal to mx double dot dot, right? You cancel this, mx double dot dot plus by kx is equal to what? 0. If we have a force excitation, okay, let's say if we have a force excitation, okay, so you have F naught sine omega naught T, then when you do your summation about forces, so I will call down here, so this is free vibration. And if this is forced, right? Again, coming down, summation of forces in the x is not equal to 0, is equal to mx double dot dot. Then this will look, I hope this is correct. So this will look like mg plus f naught sine omega naught t minus by kx minus by mg. The whole thing is equal to mx double dot dot. You cancel this, mx double dot dot plus by kx is equal to f naught sine omega naught t.
Understand. I went louder. But at the time when she what it was so loud, we had to get out of the room. I do apologize. Okay, so this is better now. Go. Okay, so I did not do this part because I just give you the general equation. Or a lot of textbooks just give you the general equation. And I realized that this class wants to learn more and more than sorry about that. No, you just need to do it. The question is, do we need to get to know all this? In case the way I teach is, I don't want you to just memorize this. I want you to know where the next goes. So in future, okay. So I know this does not sound kind to you. I don't really care how you perform in a term test. What is more important, in 2 years later, you apply this evaluation, I'll be more happy. That's what I do today. Okay? I know grades is all you, but yeah.
This might be a little bit of a, but why